Good morning. It is Friday, December the 4th, and we are kind of wrapping up ionic and covalent bonding today. The whole purpose of today's review is to answer the following questions. Do we actually understand how each type of bond forms? And do we actually understand which atoms are going to form which type of bond? So we're not going to focus too much today on the actual drawing of like Lewis structures to show the bonding, but more so on the conceptual, like, do you understand why these bonds are forming? So speaking of why bonds form, it all revolves around stability, right? Atoms are only stable if they have a full octet, meaning the outer energy level is filled with 8 valence electrons, unless you are hydrogen who can only hold 2 valence electrons, in which case we call that a duet, right? So atoms are trying to become stable. Now, just as a very quick little snippet, in case you forgot, when I reference metals on the periodic table, I'm talking about the left side of the periodic table. Elements like lithium, beryllium, calcium, potassium, strontium, these are the elements that typically we're going to see in our, I'm going to give away an answer, ionic bonds, but we'll get there, all right? So when I say metals, that's who I'm talking about. When I say non-metals, I'm talking about the right side of the periodic table. I'm talking about elements like carbon, nitrogen, chlorine, fluorine, phosphorus, sulfur, bromine, chlorine, like these guys over here. Plus, do not forget that hydrogen is technically a non-metal. Even though it's on the metal side of the periodic table, it is technically a non-metal. So, once again, we care about stability, having octets and duets. We care about the type of elements. And now we can get into the official review of ionic bonding and covalent bonding. So ionic bonding is the easier of the two because all we're doing is we're transferring electrons, literally taking one from one atom and giving it to another atom. And that transfer allows both atoms in the bond to have their full octet and to become stable. We have a little bit more details to go over, though. Specifically, the atom that is giving up its electrons, giving them away, are going to be your metals. So once again, that's on the left side of the periodic table. Elements like lithium, sodium, potassium, beryllium, magnesium, calcium, these guys only have 1 or 2 valence electrons in its outer shell. It wants to rather give them away than have to go and find like 7 or 8, right? So metals give up their valence electrons. When they give away their electrons, the balance of protons to electrons in their atoms is now unbalanced. Like it's unequal, right? Now we have more protons than we do electrons, so we become positively charged. We call them cations. Nonmetals, on the other side, want to take valence electrons. Nonmetals are the ones on the right side, so elements like oxygen, sulfur, fluorine, chlorine, bromine, right? These guys all have 6 or 7 valence electrons already. They only need 1 or 2 more and then they're stable. So they would rather take electrons. Now, when they take electrons, they become negatively charged because now we have more electrons than we do protons in our atom. We call negatively charged atoms anions, or in my head, I like to call them anions. Cations and anions, but really it's cations and anions. Now, that's the explanation for like what is ionic bonding, like conceptually. Another very important feature that like you need to get in your head is who ionically bonds. And we talk about it and stuff, but like black and white, who ionically bonds, it has to be between a metal and a non-metal. If you see a compound like calcium chloride, which is CaCl2, like in the example here, you would look at that and say, okay, calcium, is calcium a metal or a non-metal? And you would say to yourself, okay, on the periodic table, calcium is a metal. Then you say, okay, what about chlorine? Chlorine is a non-metal. So because I see a metal and a non-metal, I can already assume that they're going to be ionically bonding. Then you could go through and draw the Lewis structure like we have shown here. You can draw out the ions like we've already practiced, and then you'd be good with that problem. All right. Now we get into the more trickier of the bonding, which is covalent bonding. So what's different about covalent bonding is that we're going to, I didn't even edit this slide to say exactly what covalent bonding is. Oh no. Okay, well, I'm going to delete all this. That's funny. It's fine. I will go back and add in those details. So let me just talk about it. So covalent bonding is not the transfer of electrons. Covalent bonding is sharing electrons. Again, the goal is to try and have an octet, or in hydrogen's case, a duet. And rather than transferring electrons, why don't we just share and make everybody happy all the time, right? There are 3 types of covalent bonds. We can have single bonds, double bonds, and triple bonds. Within a single bond, we're sharing a pair of electrons, and we designate a single bond in our drawings as a single line, right? A double bond would have 2 lines, a triple bond would have 3 lines. So in this example of ammonia, NH3, this single line here tells us that there's 2 electrons that are shared between hydrogen and nitrogen. So hydrogen gets 2 atoms, which makes its duet. Nitrogen gets 2 atoms, which helps with its octet. Same thing for all these other hydrogens surrounding this central nitrogen. Now, covalent bonding, to make it like super crystal clear, who does covalent bonding? It's 2 or more nonmetals. So if you've been like kind of paying attention to our practice problems from the Jamboard and stuff, you probably noticed that when we talk about covalent bonding, all of the elements in those compounds and those molecules are coming from the nonmetal side. So think of like CO2, carbon dioxide was one of the big ones, right? So C and O, carbon and oxygen, are both nonmetals. Or we did carbon tetrafluoride, CF4. Carbon and fluorine are both nonmetals. What was another one we did? NH3. Oh, we just did NH3. But like, right, so like nitrogen and hydrogen are both nonmetals. Or what was another one? Let me think of one more. Oh, that weird one, BF3. Best friend. No, BF3. Boron. Ooh, boron's a metalloid. But then fluorine is a non, right? So we're coming from the nonmetal side. Again, covalent bonding between 2 or more nonmetals. And then, yeah, okay. I wish I had edited that slide, because then it would have helped me remember what I needed to talk about. It's fine. So that was our big review. Did we actually answer the questions how each type of bond forms? Yes, ionic is the transfer, covalent is the sharing. Atoms that typically form each kind of bond. Ionic is between a metal and a nonmetal. Covalent is between 2 or more nonmetals. The whole goal is to make sure that everyone is stable with an octet or a duet if you're hydrogen. Well, that wraps up this video. In the next video, I'm going to kind of talk you through how to answer and manipulate stuff in the POGL that you guys are going to be working on. You can watch that video, and I may or may not share out a few answers, so it's worth it. It's worth it to watch the videos. Email me if you guys have questions. Otherwise, I'll see you in the afternoon time.